I'm very excited about this presentation. I hope I leave you with a lot of excitement when I'm done with it. Exactly as Inderpreet said, it started with a need, then a lot of research, then partnering. And currently, we are at the threshold of scale-up activity for a large number of units in Jamnagar. For those of you who don't know where is Jamnagar, I'm going to give you a brief introduction as well. So my topic is going to be immersive training system platform for manufacturing. My name is Matt Malladi. I manage business initiatives in North America for Reliance, also special projects. This is one of those special projects that I undertook. And it's my pleasure and privilege to present it to you guys. So over next 20 minutes, my program is going to be who are we, what do we mean by competency assurance system and its limitations, and how a world-class assessment center with immersive training system can overcome some of these and address these issues, and various elements that went into coming up with the immersive training system. Okay. So just a little bit background. Reliance is an Indian company. It's a large company. It's privately run, publicly traded, uh, and we have manufacturing, we have telecommunications, we have retail. We just like any owner-driven company, we are into many segments, but manufacturing accounts for 80% of our revenues. And we built these plants, which are in Jamnagar, which is in Gujarat state post 1990. So we used the latest technologies available worldwide, and we brought them together in this place called Jamnagar, which used to be a simple, sleepy village. And today you go there, 19,000 acres are occupied by this complex. It is called super complex. And we consistently achieve top quartile performance as determined by Solomon surveys. And that's because we have world scale and we are efficient. So we built the largest refinery that is possible. And we have two refineries there that amount to 1.3 million barrels per day. And then we have petrochemicals that are adjacent to it, which is the latest project called J3, which makes other building blocks, petrochemical building blocks. So we are world scale, efficient, integrated, and after we finished the most recent project, which is within last year, we have rededicated our efforts to manufacturing excellence, that is focus on productivity, reliability, HSC, and quality. And we attribute that to three major things that we have. People and competencies and skills are number one. And we adopted best technology and processes and weaving robust asset designs with best operating practices. That was our third strength. And as you know, any safety paranoid company, you need to be worried about competency. And hydrocarbons are hazardous, and that's more important in hydrocarbon service. So we feel that competency assurance system, which I'll define a little bit more, is key prerequisite to avoid catastrophic events that affect people, assets, and communities. And while there are many reasons for it, previous work and many multinationals are involved in it. I depend a lot on Shell Global Solutions for this kind of information. So they came up with the fact that 71% of the incidents are due to lack of competence, and 50% are due to not following procedures. And competency assurance is must avoid and minimize these. This is not the only solution, but competency assurance along with on-the-job training, performance management system form the three legs of safe operations. So what is competence? Just quick overview. You all know it, but I just wanted to set the stage. It's the ability to perform work activities to standards required in employment. The key words are ability to perform and standards. And to make it operational, we had to come up with a competency assurance system. And the framework basically involves describing skills and competencies in a common language that applies to the workers, the frontline workers, the supervisors that work in refining industry downstream, and for which we had to come up with competency catalogs, which ranges from technology to HSE to fire and engineering and maintenance functions. And for each employee, we develop job competency profiles. That is the system. The process is to ensure that individuals meet these competencies according to established standards. Now, our focus started with the front line, and the design goes all the way up to leadership competencies. Now, there are two elements to this system. One is the competency development, which is training in regular language. And it involves robust involvement of many types of learning interventions. The four-box model is what we use, and it's called blended learning. We heavily use that, in addition to on-the-job training, which is the key. And then competency assurance is a subset of that, where you take specific HSE critical competencies and skills and you assure them in the field. Just to give you an example, if there is a plant with, say, 10 different pumps and they belong to 10 different suppliers, you want to make sure that the operator can start up and shut down and act on emergency situations on all 10 of them. So it is time consuming. It's like a prayer. To me, competency assurance, when you assure someone, it is like a prayer. Basically, you go with disciplined approach, ensure the guy who is being assured is prepared, goes through the process, answers questions. It's quite involved, and I'll show you quickly the process involved. That's what that is. We depended on Shell best practices to adopt this. And there are three elements to that. The first one is making sure that employee profiles are mapped. We don't have job descriptions anymore. We have job competency profiles. So if there is a job, there is a competency profile. And so that is the first column where you make sure whether the person is new or experienced, you map those. The middle column is where you subject them to a self-assessment and supervisory assessment. It's all driven automatically. If the person's profiles are mapped and proficiencies are unknown, the system will drive you through the system to self-assess. Then the supervisor gets involved and helps in verifying. That comes up with the training needs and requirement and also individual development plan. So that's the second column where you subject the person through learning interventions. And the third one is you isolate the critical competencies that that person is supposed to perform and ensure that they go through the assurance process and pass. And in this system, there is either pass or fail. There is no in between. And once the operator passes, he is licensed to operate. Okay. So we rolled out this system for 10,000 employees. We have 10,000 manufacturing frontline positions, which involved operators to supervisors, 8 locations. And it has limitations. And limitations are very unique to Reliance. ExxonMobil or Shell, when they employ an operator, it is for life. They retire on the job. You don't see them changing jobs. In our case, we employ engineers. They are from IITs and various places. We also have diploma holders that come in. So we have a mix of both. And when they come in have the time to get involved with industries such as refining, have the time to get prepared for their GMAT or their GRE for the next job, or go into IT industry. So we have heavy duty attrition, which is very different from what multinational oils face. Our attrition rates are in excess of 20%, and mainly from front lines, and they all go to Middle East. In fact, there was just a joke that the CEO of Aramco was at our site, and we were presenting the immersive training system. And it was presented by graduate engineer trainees that have been with the system only 4 months. And after they were done, he was very interested to know how long have they been with Reliance. And they were told not to tell him that they are just newcomers. My interest was to show that even a newcomer can navigate and get into this and engage. So they told him 4 months. And he says, when you guys are fully trained, you send me your CVs, I'll hire you. And he was sitting next to our CEO. So basically, we have heavy duty loss, and we want to make up for it. And usually, time that takes for an operator to become fully functional on all the elements in the unit, the SOPs, the routine normal operations, the non-routine normals, and non-routine abnormal events, it takes 2 to 3 years to certify, because each assurance, each competency, you have to assure in the field, and there is a method to that madness, and there is a preparation time, there is HR and a competent authority that is going through the assurance testing. Then they come back, they go through an interview for each competency, and so it's involved, and it involves live equipment, so you can't experiment with anything that is not ready. If it's live and it's working, we can't use it. And it's not always available for even on-the-job training. The routine normal is available all the time, but non-routine normal is not always available, the startups and shutdowns and so on and so forth. So our chairman came up with a challenge for us. He said, we are going to live with this attrition, so I'd like you to come up with this world-class assessment center that lets people come in and go out, and they are continuously training and getting assured. And we should cut that 2 to 3 years down to, his goal is 6 months, but it's quite aggressive. Some of those who are well informed in this area will say it's an impossible task, but we have undertaken that. And the idea is to drive rapid competency development and assurance, make sure annually it is certified again, and focus mainly on millennials, X and Y, Gen X and Y, engage, challenge, and bring some amount of speed and accuracy and point scoring kind of a situation into the training, so that they can come at any time in the evening, morning, afternoon. The room is available. There is no risk of using the system, and it's 24/7 available to explore or master tasks. So we identified immersive training system as the answer. And it is, in simple terms, it's a digital replication of equipment, plant, operations, and maintenance. In other words, a AR/VR platform with an amalgamation of training and assurance. So integrated with the operator training simulator in downstream refining, for every unit, especially at Reliance, we have something called operator training simulator, which is a dynamic model of the unit which simulates controls and operation of that specific unit. And we use it for training the panel officers before they go and really work on the live units. So when we tie the OTS to ITS, it's a complete refinery in action. And so that is the solution we have identified. And the way we did it, I want to just digress and tell you, I was looking for suppliers of technology. And it's heavily, like Inderpreet said, it's heavily fragmented. There are magic words, acronyms, and some are real solutions, some are not. And I found it very tough to really bring it together with many of the vendors. And I met even the major ones. Aviva is one of them, Schneider Electric, Honeywell, Siemens, Eon, and many others, smaller ones. And what we have concluded is that we need to ask this vendor to show me if there is anything that they have that we can see and feel before we do anything. So among the groups, I spent at least 3 days in London, Canada with Honeywell, and several days in San Diego with Ian. And Ian told me that they have a system available, and that really started the ball rolling. And it is a system that is sitting in Department of Energy. They built it, and both the architects are in this room, Graham Provost and Ian. And they took me to the site, and it was very impressive. There is operator training simulator in one room, immersive training in the other room. They are simulating a gasification, a coal gasification system. And it was any moves you make in 2D on the screens, it is showing in 3D in the other room. And same thing was replicated in University of West Virginia, same format. And it is used for process control undergraduate course, as well as bringing in coal gasification operators to train them. So that made up my mind that there is something here that we can take and build on it. So that was the starting point for our relationship. This is not ours, huh? Yeah. So I'll come back to this, right? Or do you want me to play this now? Okay. I do this. That's what precisely what Aviva did. We took this system and we adopted that for our use. So first I'll talk about this, and I'm fast forwarding. I'll give you the bottom line and then go back to how we came to this. So we identified immersive technology as a solution, and in our search we found Aviva has this system, and that block in light blue, the iSIM VR AR platform, is what they had. And then we had to worry about how do we future-proof this? How does it work? How does it interface with all the display devices that are emerging? How do we take all our data and interface it with it, depending on the application? So going from left to right, the system can take a 3D PNID and convert that into a realistic overlay of the plant. And then the OTS, Operator Training Simulator, interfaces with iSIM. And Aviva has its own OTS as well, but we use Honeywell's. And Aviva has its own product. It's called DyneSIM. Either way, they interface with this iSIM, and they run the dynamic operations and in 2D, and it is displayed in 3D. And what the iSIM does is it takes all the active objects, the valves and the fittings and the pumps that have to be activated so that when you click on it, it starts and shuts down as you are in this immersive environment, converts it into active objects, and then DyneSIM allows it, drives it to run the scenarios. So you have to define the scenario. A SOP is a scenario. SMP is a scenario. A routine normal startup is a scenario. So you work all that in, and so this pointer I'm unable to use, but I just want to show you the top manufacturing external data source is the stuff we generate. Every second we have information that's coming up, the IP21, the maintenance information, so on and so forth. And then the bottom is the display devices and the interfaces to the blue box. So we wanted to make sure that we future-proof this architecture and ensure that we can plug and play with display devices or put in data of relevance for our use. So this is how the architecture evolved. And our vision is this architecture translates to an iSIM platform which can serve many users. In fact, Interpret touched on some of them. The top left-hand side corner is the usual use of operator training simulator for engineers and operators. That is used today for any unit that we build and operate or shut down and start up. The bottom one is hands-on asset maintenance. That is where you can use HoloLens and many other aids and AR, VR as well to make it happen. And then going to the top right-hand side is the operator guidance, which is what Microsoft and Chevron showed last year, which is you are in the field and you have a question, you can ask your supervisor remotely and get guidance on that. And there are many safety events that can work into that. Basically, safety scenarios come into that picture. And I understand some of the multinationals are looking into that with that in focus. The fourth one is the big one, which is taking the 8 academies. There are 8 kinds of people that are in a refinery. They are operators, they are technical, they are, which is chemical engineers, they are maintenance and engineers, that is electrical, mechanical, instrument, and civil. Then there is HSE professionals, and then fire prevention guys. For all of them, we have competency assurance system with the scenarios. So all we have to do is translate that into the scenarios that we want, including emergency response. So that is the topic for this presentation right now. So a typical, you know, layout may look like this. There is always an instructor station who can run for training purposes, or you can make it automated so that people go through automated scenarios. And since it's enclosed and available, people can come in and go out after booking their time, and they can switch from plant to plant and train on whatever plant they are looking for. And then there are panel officers that sometimes events are team based. There is more than one person doing the activity. So you need a panel officer, you need a field executive or two. So they work as a team with communications going back and forth. It allows them to practice that team activity right there uh, rather than in the field, so that they perfect it before they go out. Now, we went through this developmental approach. We used the technology readiness level approach. When we went to DOE and University of West Virginia, we were at TRL 1 and 2 as far as we are concerned and our utility is concerned. Then we moved slowly to pilot demonstration in Jamnagar. And there we had to modify a number of scenarios and tasks to show it relevant to the refinery activities. And we showed it to at least 300 people, and a lot of dignitaries also came and gave their inputs. We collected feedback every time people came in. They would say, I wish you have this. I wish when you approach the pump, you show the maintenance data for maintenance guy and operating data for operations guy, that kind of stuff. So we collected all that. We are actually entering the TRL 5-6 stage, where we want to propose the first of a kind training assessment commercial center uh, in Jamnagar. That's where we are. Now these are the way we ran demos, and the young lady standing in the front is today she's in Rice doing MBA. So she was a graduate engineer trainee, trained her, she was top notch. Then she decided life is bigger than just being an engineer in a refinery. She went on, but there are many such youngsters that can adapt to this technology very quickly. So the focus is on a number of roles. Just to give you a highlight, I won't go into details, but operations maintenance is number one. And then we go to support functions on the right side. Then HSC, of course, is always on top of our list. Fresh recruits and visitors. So our type of visitors and type of customers that will be exposed to this depends on who is going to use and for what purpose. Now, the blue box I showed you is mainly a hardware and software architecture box. But honestly, the scenarios and tasks that you make this blue box run are the key. And so it's a three-dimensional picture, but there is competency assurance, where you take operations to fire, come up with routine to non-routine abnormal tasks. We have listed them. We have finished that. We have that as part of our CAS system. And then you have competency development where a new engineer gets exposed to a variety of things related to a plant. And so basically this whole three-dimensional system is what feeds into this blue box to make it run as needed. Now, there are three prerequisites to make it happen. One is, of course, the 3D PNID. Not all brownfield units have that, so you have to get that going. And the second one is OTS, Operator Training Simulator. And third one is converting the 3D PNID into a photorealistic graphics overlay so that it's ready along with the scenarios and tasks. So there are 9 work streams for this project, and we are ready to get going. So that's where we are. First, we have to come up with a training design. Second, we have to prepare the system to ingest all the information, make it photorealistic, tie it with OTS and scenarios. And third is make sure that hardware supports it. For a plant like ours, which has 5 different major complexes combined under one, we see more than one center. For depending on petrochemicals, we may have a petrochemical center, we may have a gasification center to do that. So we expect at least 4 or 5 centers where this will be implemented depending on the unit. So that's all I had to say. And